Hello everyone, welcome back to the channel. If you're working on your IB MYP Design project, you know that Criterion B is all about developing your ideas. And today, we are diving deep into Strand 4, the part where you create accurate and detailed planning drawings and outline what you actually need to make your solution a reality. This is where your design goes from, oh, cool idea, to here's exactly how I'm going to build this. So let's get into it. First things first, what exactly is Strand 4 asking you to do? Strand 4 has two main parts. 1. Develop accurate and detailed planning drawings or diagrams. This means creating technical drawings that show exactly how your solution will be made. We are talking about dimensions, measurements, materials, and construction details. Outline the requirements for creating a chosen solution. This is your resource list. What materials do you need? What tools? How much time? What skills? Think of it like this. If someone else picked up your planning drawing and requirement list, they should be able to make your solution without, the keyword here is, without asking you any questions. Let's talk about those planning drawings first. The keywords here are accurate and detailed. What not to do? Simple sketches with no measurements, vague labels like wood piece goes here, missing views or perspectives, no scale or proportions. What to do? Include multiple views. Depending on your project, you might need the front view, side view, top view. You might need isometric or 3D perspective drawings. You might need cross-section to show internal details, or you might need exploded views to show how parts fit together. 2. Add precise measurements. All dimensions should be clearly labeled. Use a consistent unit, could be millimeters, centimeters, or inches. Include angles if relevant. Show thickness of materials. 3. Annotate everything. Label all parts and components. Specify materials for each part. Include joining methods. It could be glue, screws, welding, etc. Add notes about colors, finishes, or textures. 4. Use proper drawing conventions. Draw to scale and state the scale. It could be 1 to 10, 1 to 5, 1 to 1, whatever it is. Draw to scale and state it. Use correct symbols and line types. Include a title block with project name, your name, date, and scale. Remember, the level of detail depends on the complexity of your solution. A simple poster design needs different planning than a mechanical device or an app interface. Let's look at what accurate and detailed planning drawings look like for different types of design projects. For physical projects or physical products, orthographic projections where we have the front, top, and side views, dimensionized drawings with all measurements, assembly drawings, detailed views of complex parts. For digital products, we have apps, websites, where we include the wireframes with exact pixel dimensions. We include the screen flow diagrams showing navigation. We include annotated mockups with interaction notes. We include the UI or the user interface component specifications. For graphic design, where we have posters and logos, we include the layout grids showing the spacing and alignment, the color specifications, where we can use RGB, CMYK, or the Pantone codes. We have the typography details, the font names, sizes, and the leading. We have dimensionized placement of all elements. For architectural or space design, we include the floor plans with room dimensions, elevation drawings, furniture layout diagrams, materials and finishes schedule. Whatever your project type, your drawings should be professional enough that someone could actually make your solution from those drawings, from the designs you have. So how do you actually create these drawings? We can use traditional tools which include the ruler, compass, set squares. we can use technical drawing pens, we can use graph paper or isometric paper. For digital tools, we can create a product design that will include, or we could use a SketchUp for the free version, Fusion 360, which is free for students, and Tinkercad, which is very good for beginners. For digital and user interface design, we can use Figma, which is free and browser based. We can use Adobe XD, or we can use Canva for simpler projects. Then for technical drawings, we can use AutoCAD if your school has it. We can use LibreCAD, it's a free alternative, or even Google Drawings for basic diagrams. The tool doesn't matter as much as the quality and detail of your final drawings. Use whatever you're comfortable with, but make sure it can produce clear, labeled, dimensioned diagrams. Now let's talk about the second part of Strand 4, outlining the requirements for creating a solution. This is basically your what I need to make this happen list. Be thorough. Think about 1, the materials list, which can include specific material names, not just wood, but pine wood 10mm thick. Quantities needed with some extra for mistakes. Sizes or dimensions, where you will source them or where you will find them, and the approximate costs. Take an example. In my table I have material, specification, quantity, source, and cost. The material I have or I need is plywood, 5mm thick, 600 by 400mm, 2 sheets. I'll go to a hardware store and could cost $15. I also need wood glue, PVA, waterproof. I need 1 bottle, school supply, and it's provided, so I don't have to incur any cost. 2, we talk about the tools and equipment. List everything you will need. Can be hand tools from saw, drill, scissors, to power tools, software digital tools, measuring equipment, and safety equipment. 3, talk about the skills required. Be honest about what you can and cannot do. What skills do you already have? What do you need to learn? Will you need help or supervision for certain steps? Step 4, time requirements. Break down how long each phase will take. Include the preparation time, the construction time or creation time, the drying or setting time, the testing and refinement time. 5, safety considerations. What safety equipment is needed? Goggles, gloves? What precautions must be taken? Do you need adult supervision for certain steps? 6, workspace requirements. How much space do you need? Does it need specific conditions, ventilation, water access, etc.? Where will you actually make this? How should you present all this in your design portfolio? Here I'm going to give you organization tips you can use. For planning drawings, use clear headings for each view or drawing. Number your drawings, i.e. drawing 1, drawing 2, etc. Make sure the text is readable. It should not be too small. Use high quality images if you've drawn by hand and are scanning. For the requirements, use tables or organized lists. Group similar items together. Be specific with quantities and specifications. Show that you have actually thought through the process. The SWOT test. Ask yourself a simple question. Could someone else make my solution using only my drawings and requirements list? If the answer is no, add more detail. Let me share the most common mistakes I see students make with Strand 4. Mistake number 1, vague measurements. A medium-sized piece of cardboard, corrugated cardboard, 300mm by 200mm by 3mm thick. It doesn't make sense. Mistake number 2, missing views. Don't just show one angle of your product. Show how it looks from all relevant perspectives. Mistake number 3, forgetting the little things. It's not just about the main materials. Did you remember adhesives, fasteners, finishes of paint, packaging materials? Mistake number 4, Unrealistic requirements. Make sure you actually have access to the materials and tools you're listing. If you need a laser cutter but your school doesn't have one, you have gotten a problem. Mistake number 4. No scale or proportions. Always include scale on your drawings. A full-size drawing is fine for small items, but state that it's a 1:1 scale. Let's look at a real example. Say I am designing a font stand made from wood. My planning drawings would include drawing 1, front view, 1:2 scale. It shows the overall shape and height, 150 mm. It shows the base width, which is 80 mm. It shows the angle of the font rest, which is 65 degrees. It shows the groove depth for font, which is 10 mm. Drawing 2, side view, 1:2 scale. It shows the base depth, which is 100 mm. It shows the thickness of wood, which is 15 mm. And it shows a curved radius at the top, which is 20 mm. Drawing 3, which is a top view, 1:2 scale. It shows the groove width. It shows the side support positions and shows the screw hole locations. Drawing 4, the 3D isometric view. It shows how it all fits together. It labels for each component and also shows assembly notes. My recommended list would include materials, which include pine wood, 15 mm thick, 300 mm by 200 mm piece, sandpaper, 120 grit and 240 grit, 2 sheets each, wood finish, clear varnish, 100 mm, non-slip rubber pads, 4 pieces, 10 mm diameter. The tools I will need: jigsaw or coping saw, drill with 3 mm and 8 mm bits, sandpaper block, paintbrush for varnish, pencil and ruler for marking, safety goggles, and dust mask. Time: cutting I'll use 30 minutes, sanding 45 minutes, finishing 20 minutes plus 2 hours drying time. Assembly I will use 15 minutes. Skills needed: basic sewing skills, I have this. Drilling accuracy, need to practice. Finishing techniques, will research tutorial. Safety goggles required when cutting and drilling. Dust mask for sanding. Other supervision needed for power tools. Work in well-ventilated area for varnishing. Want to know what moves you from a basic level to a highest achievement level? For a basic level 3 to 4, include some planning drawings with basic dimensions. List main materials needed. Drawings might have some missing details. For a proficient level 5 to 6, include multiple detailed drawings with most dimensions, comprehensive materials and tools list, mostly accurate and workable plan. For the excellent level 7 to 8, highly detailed, accurate drawings from multiple angles, every dimension clearly marked, comprehensive requirements covering all aspects, professional presentation. Someone could realistically create a solution from your documentation. The difference is in the detail and the accuracy. Don't just list wood. Specify exactly what type, what size, what thickness. Don't just draw a box, show every measurement that matters. Before you say you are done with Strand 4, run through this checklist. Multiple views or perspectives shown. All major dimensions included. Scale clearly stated. Material specified on the drawing. Joining methods indicated. Clear labels and annotations. Professional and neat presentation. Could someone build this from your drawings alone? Check the requirements too. Complete materials list with specifications. All tools and equipment listed. Quantities and measurements included. Time estimates provided. Skills assessment included. Safety considerations addressed. Cost estimates if relevant. Sourcing information included. And that's Strand 4 of Criterion B. Remember, this is where you prove that you can take your design idea and turn it into an actual workable plan. Your planning drawings and requirements list should be so clear and detailed that anyone with the right skills could pick them up and create a solution. What are our key takeaways? Be specific with measurements and materials. Show multiple views and perspectives. Include everything needed to actually make your solution. Think like someone who's never seen your idea before. Professional presentation matters. If you found this helpful, give it a thumbs up and subscribe for more IB MYP design tips. Drop a comment below if you have questions about your specific project. In my next video, we'll be covering Criterion C, creating the solution, where you will actually make what you've planned here. Thanks for watching and don't forget to subscribe.